Hello everyone, I'm Snehashis Majhi. I'm gonna present our work OE-CTST Outlier-Embedded Cross-Temporal Scale Transformer for weakly supervised video anomaly detection. In this work, we target to detect the real-world complex video anomalies such as abuse, arrest, explosion, road accident, so on and so forth. The key challenges here is to detect the long and short length anomalies simultaneously that has distinctive features characterizing sharp progressive temporal cues. Second one is to due to the lack of precise temporal information, the temporal modeling is limited. Third one is due to the limited temporal modeling ability of the transformer based method. It is because of two main reasons, that is the conventional position encoding and the fixed scale tokenization scheme. In this work, the objective and idea is to precisely detect the long and short length anomalies by uh, cross-temporal scale relation modeling. And for this, we propose a CTST, that is a cross-temporal scale transformer, to effectively encode the global temporal relation in long and short length anomalies. To tackle this, to tackle the lack of temporal annotations, we propose a anomaly-aware position embedding scheme by an outlier embedder for better global temporal relation modeling. So here is the proposed framework of the OE-CTST, which has two main building block. One is outlier embedder and a cross-temporal scale transformer, and the detector detect the temporal anomalies. And the outlier embedder can be any autoencoder architecture can be used in this outlier embedder in a plug and play manner. So we saw the three distinctive design choices, that is a temporal autoencoder, spatiotemporal autoencoder, and a unit. And next, to focus on the cross-temporal scale transformers, the key building block is the cross-temporal field attention, so which essentially encodes the relation between the temporally neighbor and the temporally distant tokens. The overall network is optimized, is a jointly trainable with two disjoint batches of input, and the outlier embedder is optimized using the reconstruction loss, and the CTST with the detector optimized using the self-rectifying loss. In this work, we perform the experiments on three datasets, that is the UCF-Crime, X2 violence, and IITB-Corridor dataset. And from the ablation studies, we see that the impact of all our relevant components has a higher significance in achieving state-of-the-art performance. To see the qualitative analysis, we study our method upon three cases. The case one for the short anomalies, where the anomalies are detected precisely. Even for the long anomalies, the anomalies are detected with the tight temporal boundaries, and the activations from the position embedding has a higher activation in the anomaly localized region. In terms of the state of the art performance comparison, our method achieves the best performance and with the two backbone, that is the I3D resonate and the video swing, in overall performance and the long shot performance. Our method is also computationally competitive, and it has relatively acceptable G-flops and the inference speed in terms of frames per second. The summary of the work is, in this work we propose a novel temporal transformer that generates anomaly-aware temporal position information thanks to an outlier embedder. And the second one is we propose a cross-temporal scale transformer that learns the correlation between the temporal neighbors and distant tokens. The general idea is to precisely detect the long and short length anomalies. As an advantage, we achieve best overall and long shot performance results on benchmark datasets like UCF-Crime, X2 violence, and IITB-Corridor dataset. In future, we'll use multiple modalities for complementary representation learning. Thank you for your attention. In future, we'll release the code, and if you have any questions, you can shoot me an email.